Let's talk about one of the most maddening things about AI today. Why does it feel like they have the memory of a goldfish? You show it something, and 2 seconds later, it's forgotten everything. Well, today we're going to break down some new research that introduces a pretty cool breakthrough called reasoning bank. It's a whole new way to give AI a memory that actually learns from its own experience.
So let's just start with the core problem, right? Why do these AI agents keep making the same dumb mistakes over and over again? You've probably felt this. You ask an AI to do something, it messes up, you try again, and bam, it makes the exact same error. It's because most of them are literally designed to start with a blank slate every single time, and that is just so inefficient.
And this really puts it in perspective. Look at us humans. We learn, right? We adapt. We, try not to touch a hot stove twice. We build on our successes, and maybe even more importantly, we learn from our failures. Then you've got your typical AI agent over here. It starts fresh every time, repeats the same mistakes, and just throws away all those valuable insights, good and bad, the second a task is over.
So here's the game plan for today. First, we're going to dig a little deeper into this goldfish memory problem. Then we'll introduce reasoning bank. After that, we'll get into its secret sauce, how it learns from both success and failure. Then we'll cover a way to supercharge that learning, look at the really impressive results, and finally, talk about what this all means for the future of AI that can evolve all by itself. All right, let's jump right into part 1, the goldfish memory problem, and why the ways we've tried to fix it so far just haven't really worked.
So one common idea is something called trajectory memory. And honestly, it's like giving the AI a messy, unfiltered diary of every single tiny thing it's ever done. It's super long, it's noisy, and it's just way too specific to be useful for a new, different task. It's just a data dump.
Okay, so another approach is workflow memory. This is a little better. It's more like a playbook of moves for tasks that actually worked. But what's the giant glaring problem here? It only learns from success. It completely ignores all the incredibly valuable lessons you can only learn from failure. And that's a huge missed opportunity.
And that brings us right to section 2. And this really elegant solution the researchers came up with, reasoning bank. And a great way to think of it is like the AI's own personal reasoning journal.
So here's what you really need to know. Reasoning bank isn't just writing down what happened. It distills. It boils down the experience into high-level, reusable strategies. And here's the absolute kicker. It does this for both the good times and the bad, the successful runs and the failed ones. That right there is the game changer.
And what's brilliant is the self-improving loop this creates. So first, before it even starts a new job, the agent checks its journal and retrieves relevant strategies. Second, those memories actually guide its actions. And third, when it's all done, the whole experience, win or lose, gets analyzed, distilled into a new piece of wisdom, and added right back into the bank. It's this closed loop that lets the AI just keep getting smarter.
And you can really see the difference here. This isn't some messy log file. It's a clean, high-level strategy. It's not just click this button. It's detect the pagination mode, or here's how to avoid infinite scrolls. This is distilled wisdom, not just a boring list of actions.
Okay, let's move on to section 3, because this is where we find the real secret sauce to making the AI smarter, its ability to learn from what goes wrong.
This chart just lays it all out, plain and simple. The old ways, they only stored the successful plays, totally ignoring mistakes. Reasoning bank, it does both. It actually distills preventative lessons from its screw-ups, turning those failures into constructive, useful signals for the next time around.
And look, this isn't just a nice theory. The data totally backs it up. The study found that when Reasoning Bank only learned from its wins, it had about a 46.5% success rate. But when they let it learn from its failures too, that number jumped to almost 50%. That's a serious performance boost, and it proves that learning from your mistakes is absolutely critical.
So, section 4, we have this really powerful learning system, but how do you speed it up? How do you put it into overdrive? Well, that's where this technique called MAT-TTS comes in. You can basically think of it like an intense cram session for the AI before a big test.
MATS, which stands for Memory Aware Test Time Scaling, is all about giving the AI more practice. It massively scales up the agent's experience by throwing tons of different scenarios at it for a single task, letting it learn way, way faster. And this creates this amazing synergy, this awesome feedback loop. A better memory from Reasoning Bank helps the agent explore more effectively and more intelligently during all these practice runs.
And then, in turn, all of that rich, diverse practice is used to build an even stronger, more robust memory. It's this powerful upward spiral. A better memory leads to better practice, which leads to an even better memory. It just keeps getting better.
So, what actually happens when you put all this together? Let's get to the good stuff in Section 5 and look at the pretty impressive results. The data really does speak for itself here. The results from the Web Arena benchmark are, well, they're striking. An agent with no memory at all gets it right about 40% of the time. Other memory systems give it a little bump, but the agent using Reasoning Bank, it just leaps ahead to almost 49%. I mean, it's not even close.
And if you want one big, powerful number to hang on to, here it is. The researchers saw up to a 34.2% relative improvement over the baseline models. Now, in the world of AI research, an improvement that big is a massive deal.
And get this, it's not just more effective, it's also smarter about how it gets the job done. The agent with Reasoning Bank was more efficient, solving tasks with 16% fewer steps. So it doesn't just get the right answer more often, it gets there faster.
And all of this leads us to our final section, which is the really exciting part. What does this mean for the future? We're talking about self-evolving AI.
Now this is just fascinating. This shows how a strategy can literally evolve inside the Reasoning Bank over time. You know, it starts as a really simple command, like click on the next page button. After a few tries, it learns to add a little self-correction, like recheck the button's ID first. And eventually, that simple rule matures into a complex, adaptive strategy. The AI is actually truly learning how to reason at a higher and higher level, all on its own.
So what this is really all pointing to is a practical way for AI agents to constantly improve themselves, to learn from their own lived experience, both the good and the bad. Which kind of leaves us with one final big question to think about. If an AI can really truly learn from its own mistakes, what can't it eventually learn to do? Thanks for joining me.